This is Matt Whitmer from Birdie Precision, and welcome back to Networking 101. In this video, we will be looking at wireless hardware. Like our wired hardware, we're still located at the layer 1 in the OSI model, which is the furthest away from the user, and it is where we have our physical devices, hardware, and cabling. So if we look at the two different kinds of devices that operate on Wi-Fi, we have access points and client devices. An access point is a device that allows wireless devices to connect to a physical network. It's basically the device that's broadcasting the wireless signal from the wired network. The client is the other side of that. It's what connects to the wireless network that's being broadcast by the access point. With the devices that we see in the HVAC world, like a Jace 8000, an Easy IOFW controller, or something like this Phoenix Contact FLW LAN device here, they both can operate in either an access point or a client mode. So they can broadcast a signal to allow devices to connect to them, or they can connect to an existing wireless network that's out in the field. How Wi-Fi works. The first piece is probably the piece that most people are familiar with, maybe just didn't know the name. It's an SSID, it's a service set ID, and that's the name of your wireless or your Wi-Fi network. When you open up your wireless settings on your laptop or on your phone, all of the names of the networks that pop up there, those names are the SSIDs of the networks. Security on a wireless network is important. You don't want random people jumping onto a network that you don't know, that aren't authorized to jump onto the network. So the protocol that's used today most often is WPA2, and that comes in two different flavors. There's the personal version, and that's the version that most people are used to seeing, where there's a PSK, a pre-shared key, which is essentially just a password that you punch in to jump onto that wireless network. Enterprise operates a little bit differently. It uses an authentication server that could be running on the wired network somewhere, and it allows the IT department to manage what devices and what users are allowed to connect to the network without having to have a key that gets shared with people that they need to punch in to get onto the network. Wireless uses two different frequency bands, 2.4 gigahertz and 5 gigahertz. 5 gigahertz allows higher speeds, but is much worse with obstructions. So typically, you want to have both 2.4 gigahertz and 5 gigahertz, and at the very least, you want at least 2.4 gigahertz. That 5 gigahertz inside of a building, you're much more likely to run into issues because things like walls will definitely cut down on your ability to connect over 5 gigahertz. The channel is the smaller segment of those frequency bands. So if we look at the diagram here, we have 14 different channels, and they are all 22 megahertz in width, and basically we can choose exactly what portion of that 2.4 gigahertz in this case that we want to use for our network. Typically the access points will do this sort of by themselves, and they'll find the band that's least congested. As you know, you can't really go anywhere today and not see a whole bunch of Wi-Fi devices or access points running when you open up your phone's Wi-Fi settings. So the access point will try to find the band that's least congested. The bands that tend to be the most frequently used is 1, 6, and 11, because there's a little bit of a gap between them, and they don't overlap one another. So you've probably heard some of these wireless standards before mentioned. They used to go by a letter designation, 802.11b or G or N. More recently, the Wi-Fi Consortium has changed the naming scheme to be numbers so that it's a little bit more, or it's a little bit less opaque. It's a little bit easier to understand what's faster than what. But if we look There were a couple different specs that came out that were only 5 gigahertz. We won't run into those really ever, and ideally you wouldn't use them. The one that we will probably see most often is N, as it has 2.4 gigahertz and 5, and we're talking speeds of basically at least 100 meg up to 600 megabits per second, which is plenty for our needs. Obviously, those link rates change depending on your signal strength and how far you are away from your access points. Wi-Fi 6 is just recently adopted, and it allows for nearly 10 gigabit per second speeds, and it actually throws in some other frequency ranges as well, but we won't see that very often. So some Wi-Fi use cases. This is your typical use case where you've got a router and you've got an access point connected to that router, and you've got a bunch of clients out in the field that are connecting to that access point. That's a typical regular Wi-Fi use case that you would see, with your phone or with EasyIO FW controllers in this case. But with Wi-Fi, you can also do some cool things like point-to-point. In this case, we've got a router, a couple devices on that local network, and then we've got a PoE injector that's throwing power into our line here so that we can power a Wi-Fi access point. And then we're talking to a different building over Wi-Fi where there's another client. Now this radio is being configured as, so that this Jace is accessible by all these devices. And this Jace, for its purposes, thinks that it's on the same network as this. These devices are transparent from a networking point of view to all the devices that are there. This is a really cheap solution, gives you very, very good coverage so long as you have line of sight, and the speeds are pretty amazing too. We're talking line of sight, you could go 2 kilometers plus with these Ubiquiti NanoStation devices. So that does it for the wireless hardware side of things. In our next video, we'll be looking at network topologies.